Today I will consider one more linear model, I mean the physical system described by linear equations, which is the set of problems called mixing. It is all about the following simple experiment which you can easily do yourself. Imagine that you have a cup of coffee. Now you drink this coffee and a little bit remains on the bottom, yeah? And then you pour water here, yeah? And it fills this cup, and then it spills over the rim, and you see here, first you see dark liquid, coffee with some water, yeah? Then the coffee is going down, it is replaced by water, and so the liquid in the cup becomes lighter and lighter, and soon you see just clear water. Yeah. This is the process which is sort of washing out, and it is one of the most popular processes both in nature and in, say, chemical technology. Yes, and even this process is maybe, if you consider it as it is, it may be crazy, difficult to describe with more or less good accuracy, so we have to simplify and consider some simplified systems. So we consider first the following situation. We have a vessel which can be called a tank, yes? We have two pipes, one is going inside, other is going out. So let me draw it, say, here. Here we have water with some solution of something, some additive. Say it can be salt or sugar or some paint or maybe some hydrocarbon. Okay, no matter. It flows in with some rate Q, so how many cubic meters enters per unit time. Here we have the liquid goes out, say with the same rate Q. Now we have something dissolved in this water, which has concentration C. C is the mass of concentration, the mass of this additive in unit volume. Say we have salt, so it can be described by the say the mass of the salt in cubic meter or in 1 liter, whatever, and it is called concentration. Here it enters with some constant concentration C1. And now here it goes all this, here may be different concentrations. Say in the beginning here was concentration C, 0, and in general here is concentration C of T. Because if C0 is different from C1, then necessarily concentration here will change. Now we have to keep this solution homogeneous, yes? So we have to add here some device for stirring this, some stirrer. And all this tank has a volume V. And from the beginning this tank is filled by solution with concentration C0. Here comes enters solution with concentration C1, and here enters exits the solution with the same concentration C of T. Yes, so it is going out here, and the question is how to find this C of T. This function, how the concentration depends on time. Okay, let us solve this problem. So let m of t equals v times c of t. It is total mass. Of they say salt in the tank. So, and let us find a differential equation for first for m of t. dm dt equals. So it is what is the rate of entering of this salt through the input. So it is Q1 C1. It is how much salt is entering per unit time here. Minus Q C1 minus Q C. Yes? And now what is M? M is V times C. So C of T equals 1 over V M of T. So we have 1 dC dt equals 1 over V dm dt. Yes? Because V is constant. Equals 1 over V Q C1 minus Q C. Yeah? Or dC dt equals Q divided by V from here, C1 minus C. So dC dt plus U over VC equals Q over V C1. Now the integrating factor is e to the power integral Q over V dt equals e to the power Q over V t. Yes, so multiplying by this integrating factor, we have e to the power Q over V t dC dt plus Q over V c equals e to the power Q over V t C1 times Q over V C1. is Q. Now it is the same as, okay, let me temporarily erase it. D dt E Q over VT C equals D dt E Q over VT C1. Yes, it is also derivative. So this means that E Q over V T C equals e to the power Q over V T C1 plus some constant. C is already busy, so I write, denote this constant by A. C of t, it is C function of t, equals C1 plus A E minus Q over V t. What is A? We have initial condition, C of 0 equals C0. It is initial concentration in the tank. So substitute here C of 0 equals C1 plus A. T is 0, so this is 1 equals C0. A equals C0 minus C1. And after that, substitute here C of t equals C1 plus C0 minus C1 E minus Q over VT. So this is the answer. Very simple. So it is T. For example, initially we have some solution there, say solution of coffee. Yes, then we started pouring water. Concentration of coffee was C0 and C1 was 0. So 0 is C1 and here is C0. So initially was C0, so C1 is 0, C0 minus C1 is C0, E minus Q over VT. So the concentration of coffee decreasing exponentially like this, goes to 0 as an exponent. This means that we know that exponent goes to 0 quite fast. So after some time we'll see just clear water, and in principle there is just a few molecules of coffee there. So you will have a clean cup. So it is a quite simple situation. And now consider a little bit more interesting situation. Suppose we have again a tank and we have two tubes one is entering and the other is exiting. But this time the rate of inflow and outflow may be different. So here enters the solution with the rate Q1, and here exits solution with the rate Q2. Concentration here was C1. Here we have some volume of water. Initially did not fill all the tank. And here we have, first of all, volume which depends on T, because Q1 different from Q2. So if Q1 more than Q2, then the water level goes up, otherwise it goes down. And here concentration C of T, and C of 0 equals C0. And you have the same problem. So let us consider this problem. So this is water. So water and water with with solution, say of salt or coffee or something else. So first of all, the volume V of T equals V0. It is the volume of water at initial moment, plus Q1 minus Q2 T. This is inflow, this is outflow, this is the total, which can be either positive or negative, and times T. Now, consider the mass of the salt in this water. And let us write the balance. What is the rate of change of this mass? dm dt equals Q1 C1 minus Q2 C2 C of T. Yeah. Here enters the water with concentration C1, and here exits water with concentration C of T. And this concentration is constant, and this is variable. And now let us express M in terms of concentration. M of T equal C of T times V of T. Yes? So dm dt equals dc dt times V plus C times dV dt. Okay, and now let us write the same substitute here. dc dt times V. V is here V нулевое, plus Q1 minus Q2T, plus C dV dt, if you see, dV dt equals Q1 minus Q2. Q1 minus Q2 equals Q1 C1 minus Q2 C. So dc dt times v0 plus q1 minus q2 t. Now what about c? Here is plus c q1 minus q2 and c here minus q2c. So this minus q2c, this minus q2c cancels. So q1c, this term cancels, equals q1c1. Now let us divide it by this term dc dt plus q1 v0 plus q1 minus q2 t times c equals q1 divided is 1 v0 plus q1 minus q2 c1. So this equation, this is a function of t. This time is not constant, it is this interesting function. And now let us, I don't want to repeat all the time this term, so let me transform it a little. q1 divided by v0 plus q1 minus q2 t equals q1 divided by q1 minus q2, q1 minus q2 times 1 divided by v0 q1 minus q2 plus t. And let me introduce notation. Okay. The following notation. q1 divided by q1 minus q2 equals alpha. And v0 divided by q1 minus q2 equals t0. So why it is t0? The function v of t, this t, this v. It is v0 plus v0 plus q1 minus q2 t. Yes? So at time 0 it is v0. Now suppose q1 more than q2, then this is growing function, linear function, and if you continue it back, then at some moment it was 0, and this moment is exactly minus t0. Yeah, so this is No, this is no, just notation alpha. And with this notation, you have the following equation here: dc dt plus alpha divided by t plus t0. Yeah, it is t0 and t times c equals alpha divided by t plus t0 c1. Yeah, so the life is much better now. Okay, so the integrating factor equals e to the power integral alpha divided by t plus t0 dt equals e to the power alpha. Integral of 1 divided by t plus t0. No, here let us do the following. Suppose for a moment that alpha is positive, yes, and t0 is positive. So this means that everything is positive. It is logarithm t plus t0. Mu equals simply t plus t0 to the power alpha. Okay, now multiply both parts by this mu, and so we have d dt of t plus t0 to the power alpha c equals, wait, let me write, t plus t0 to the power alpha of dc dt plus alpha t plus t0 times c equals t plus t0 to the power alpha times alpha t plus t0 c1. Now c1 is a constant, it's important. Now if you insert it inside the brackets, then you see that this is derivative of t plus t0 to the power alpha times c, yes? And this is derivative of t plus t0 to the power alpha c1. Yeah? The difference is that here c is a variable function, and here c1 is a given constant. From here, t plus t0 to the power alpha c equals t plus t0 to the power alpha c1 plus again some constant, and again I denoted by a simply because c is busy. Divide by this factor c of t equals C1 plus A times T plus T0 minus alpha. And then what is A? You have to substitute here T equals 0 and have C of 0 equals C1 plus A T0 minus alpha. Yes? Which is should be equal C0. It is initial concentration. So A times T0 minus alpha equals C0 minus C1. A equals T to the alpha C0 minus C1. And finally we have the answer. The answer is, substitute this here, C of T equals C1 plus C0 minus C1 T to the power alpha times T plus T0 T0 to the power alpha. Minus alpha. Oh. And here we assume that alpha was positive. We solve. In fact, here we have two cases, positive alpha and negative. So now we solve for positive alpha. No, it is the answer. Because no, this is solution. And see, if say this is C0 and this is C1, yes, this is T, this is C of T. So what we have, this is constant, this is constant, this is constant, and this function, if alpha is positive, this function goes to 0 when t goes to infinity. Monotonically goes to 0. So we have approximately this picture. So it looks superficially like in the previous case, but when q1 equals q2, this is exponent, so it goes to 0 fast. This is a power function. This power function, so it goes to 0 but much slower. That's it. Now the second case is when q1 is less than q2. One moment. So our equation is dc dt plus alpha divided by t plus t0 equals alpha c t plus t0 c C1. And consider the case when alpha less than 0. So alpha is this. This happens that when Q1 is less than Q2. Yes, in this case here we enters less liquid then here it goes out. So the level is going down, and we have the function like this. And so this is minus alpha, minus T0. And T0 is negative because the same denominator, which is negative, and alpha is negative. T0 is negative also. In this case, it is more convenient to a little change notations. One moment. So we write alpha equals minus beta, and T0 equals minus S0. Then this is S0. Okay, and then our equation becomes the following. If you substitute alpha is minus beta and T0 minus S0, dC dt minus beta divided by T minus S0 C equals minus beta T minus S0 C1. The same equation, because this equation was good for both positive and negative alpha. And this equation, no, it is in our new notations, or better to change places T and C and S0 and have the following: dC dt plus beta S0 minus T C equals beta S0 minus T C1. No, okay, mu equals e to the power integral beta S0 minus T dt equals e minus beta logarithm S0 minus T. Yeah? I change of sign because here is in denominator S0 minus T. Yeah? Which is equal to S0 minus T minus beta. Okay. So multiplying by this integrating factor, and again this we get here the derivative of c times this integrating factor, and we have the following: d dt S0 minus t to the power minus beta c equals minus beta S0 minus t beta S0 minus t times S0 minus t minus beta C1 or d dt S0 minus t minus beta c equals d dt S0 minus beta S0 minus t minus beta C1. So if you differentiate this, we have minus beta and again minus from minus t, it's okay. Or S0 minus t minus beta c equals S0 minus t minus beta c1, no, plus some constant b. Yeah. So if derivatives of two functions are equal, then this function differ by constant. So divide by this factor c of t equal c1 plus b S0 minus t to the power beta. And what is b? Again, go to the initial condition. C of 0 equals c1 plus b t equals 0 s0 to the power beta. And this should be equal c0, initial concentration. So b equals b s0 to the power beta equals c0 minus c1. b equals s0 minus beta c0 minus c1. It is a constant. And this solution, let us substitute this constant. C of t equals c1 plus c0 minus c1 s0 minus beta s0 minus t beta. Now, let us write it in this form. C0 more expressive plus C1 C0 minus C1 S0 minus t divided by S0 to the power beta, which is equal to equal C0 C1 C0 minus C1 times 1 minus T divided by S0 to the power beta. So for t equals 0, this is 0, so C1 plus C0 minus C. So it is C0, and when this factor becomes 0, it becomes C1. So what is S0? S0 is the moment, after all, S0 equals V0, Q2 minus Q1. So this is the rate of our total outflow. We assume that Q2 more than Q1. So the volume of water in the tank, V0, was decreasing with the rate Q2 minus Q1, and it becomes 0 exactly at the moment C S0. Yeah? And so what we see, let us look at this solution. First of all, this solution makes sense only for t between 0 and S0, because at the moment S0 we have no water in the tank. Yes? So what will happen next? Next will happen the following. From the, okay, it will look like this. Here comes water with the rate Q1. This pipe is wider. Let me draw it wider. It has more section, is higher. But it cannot extract from the tank more water than there is there. So if the water is just on the bottom, yeah, and it's coming with the rate Q1, then it will go out with the same rate Q1. Yes? And if it came with the concentration of salt C1, then automatically here concentration of the outgoing salt is also C1. And what is in between when we have some water? Let us look at this solution. S0. So here was C0. Yes. Now suppose, for example, that C1 is 0. So we first the water had solution of our substance with concentration C0. This concentration C0, and then at the end, from this tube enters water with concentration 0. I mean just clear water. So here clear water. Here was some solution of salt. Yes. Then this formula shows that. If, say, C0 was 0, C of t equals C0, C1, if 0 is 0, for example, then, so here 0 minus C1, 1 minus t over S0 to the power beta equals, this cancels, C1 times no. C1 equals 0. Then C of t equals simply C0, 1 minus t over S0, the power beta. Yes? So 1 minus t over S0 is this function. So if beta is positive, no, depending on relation between Q1 and Q2, so beta equals Q1 divided by Q2 minus Q1. So it can be arbitrary positive number from 0 to infinity, depending on the values of Q1 and Q2. So say if beta is equal 1, we have this function. It is equal 1. If beta is more than 1, we have something like this. If beta less than 1, it is something like this. Yeah? But in all cases, it starts from 0 and ends here, starts from 1 ends here at 0. And here is multiplied by C0. Now if C1 is not 0, it all is lifted by C1. So all in all, for arbitrary C0 and C1, say this is C0, C1. Here as 0. Then solution will look as follows. No, say if beta is less than 1 here. Solution is the following. We start from concentration C0, then it goes down and then reaches C1 here, yes, like this. And then, if we did not stop this process, the outgoing solution will be have all the time concentrations C1. So it will be this interesting solution. No, okay. I wanted to consider some numerical example, but I think you have such simple formulas that you can substitute yourself. If you have questions, please ask me. Let's finish with this topic now, and then we'll start nonlinear models. It's also interesting. For now, let's finish. Have a good time. Bye.